All right, our last section in this chapter is just looking at other ways of writing proofs. So we've been doing two-column proofs, which is how a lot of people in geometry do proofs. But I want to show you the last two options, or two other options we go over in the book as well, flowchart and paragraph proofs. And really, it's up to you how you want to write your proof. I'm not going to be picky and tell you to specifically use a format. So you want to figure out what is most comfortable and makes the most sense for you. All right, so flowchart proofs are what we're going to go over first. And I think the easiest way to look at these now is to look at the two-column proof that we're very familiar with and see how we can rewrite it as a flowchart proof, okay? So let's take a look at this two-column proof first and make sure you understand it. So if we're looking at this two-column proof, you'll see that, okay, we are given angle 2 is congruent to angle 4, right? And we're trying to prove that the measure of angle 1 is equal to the measure of angle 3. Something you want to note when you're looking at what you're trying to prove and looking at what you're given, when we're going from congruence to measurement, this probably means we need to use that definition of congruent at the end. So that's always a good hint, right, to look at the format, okay? And you can think through the proof or look down here and see how it's done, but I encourage you to make sure you go through the logic and make sure it makes sense. So we're given that angle 2 and angle 4 are congruent, which is awesome. From your diagram, we know that angle 1 and angle 2 are a linear pair, and angle 3 and angle 4 are a linear pair. I would even add that in here as part of this proof, saying that angle 1 and angle 2 are a linear pair. That's pair, and angle 3 and angle 4 are a linear pair. As part of your givens, because it's given here in the diagram, right? But anyway, I would add that in. It's up to you if you would or not. I probably wouldn't take off any points as long as you have this linear pair theorem, which is super important. All right, so we know that we have two pairs of linear pairs, so that means angle 1 and angle 2 are supplementary, angle 3 and angle 4 are supplementary. And since they are supplementary to the same angle, basically, because 2 and 4 are the same, so basically we're saying 2 and 4 are the same angle, there's this theorem that we call the congruent supplements theorem. Don't mind my dog. That we can use to prove that angle 1 is congruent to angle 3. All right, and since they're congruent, we can say that they are equal by the definition of their angles. Now, if you don't remember this congruent supplements theorem, and to be very honest, I never do. Instead of doing this, what you can always do is you can break this apart and say that use the definition of supplementary. So we can say instead, use the definition of supplementary to say that the measure of angle 1 plus the measure of angle 2 is equal to 180, and also the measure of angle 3 plus the measure of angle 4 is equal to 180 by your definition of supplementary. And then since they're both equal to 180, I can say that they're equal to each other by substitution. And since angle 2 is congruent to angle 4, I can say that measure of angle 2 is equal to the measure of angle 4. Make that a little clearer by your definition of congruence. And then I can basically just subtract and say the measure of angle 1 is equal to the measure of angle 3 by your subtraction property of equality, because I'm just taking away measure of angle 2 right here and measure of angle 4 right there, since they're equal to each other. And honestly, that's probably how I would have proved it, because again, I never remember the congruent supplements theorem, and you can feel free to use it. Again, it just says if you have two congruent angles that are supplementary, right, to a different number, to a different angle, then those two other angles are congruent, right? Since we know 2 and 4 are the same, and 1 and 2 are supplementary, 3 and 4 are supplementary, that means 1 and 3 have to be the same number. Again, don't remember it. Don't worry, you can just do what I did over here and use a few extra lines to prove it. Never worry about doing the shortest proof possible. You always want to make sure your proof makes the most logical sense. So I want to encourage you guys to remember that. Don't worry about making your proof 4 lines, right? I don't care if it's 10 lines. I don't care if it's 20 lines. As long as it makes logical sense and it works start to finish, then you're getting full credit. If you only have 4 lines and it makes absolutely no sense, that's 0 credit. So please don't feel like pressured. You have to use the smallest number of lines possible. Okay? So that being said, let's take a look at this flowchart proof. So when you're doing a flowchart, it's basically like a flowchart you've probably done in the past, right, in a history class or an English class. And personally, I like flowcharts to brainstorm. So what you do with the flowchart is you can draw boxes or circles like you normally do, and you can go sideways or you can go vertically. Doesn't really matter. But what you want to do is you want to start with your given. So I'm going to start with my given. And that's going to be circled or it's going to be boxed. It doesn't really matter what you do with that, all right? And then underneath it is going to be the reasons. So statements go inside the box and reasons go on the outside. So let me just make a note of that, guys. Remember, so again, statements in the box and then reasons below. And again, you can use a circle. You don't have to use a box. I like using the box, okay? But what's important from here is how everything is linked. So if I want to use more given, so for example, if I'm going to add in that given angle 1 and angle 2 are a linear pair, right, as my given, and also angle 3 and angle 4 are a linear pair. I can line them all up like this, but because they have nothing to do with each other, those arrows in your flowchart aren't going to link these boxes together. What you want to do is you want to link a box to the following statement, right? And since they're both linear pairs, what I can do is I can put them together and say that, well, angle 1 and angle 2 are supplementary, right? And angle 3 and angle 4 are supplementary. And this is why I like the flowchart. It's because you can actually put arrows and link things together. So I like doing this as a brainstorm. All right, and this was your linear pair theorem. All right, that's its linear pair. Oops. Oh, let's rewrite that. All right, my handwriting is out of control today. Oh, my bad. Okay, so let's go ahead and use the original 2-column proof here to finish this off. But again, you could do what I have in red too. It's just going to be a little longer, but still 100% accurate. And if that makes the most sense to you, you need to go with that. Okay, so if I know angle 1 and angle 2 are supplementary and angle 3 and angle 4 are supplementary, and I know that angle 2 is congruent to angle 4, then what I can do is I can put these two pieces of information together. So notice how these arrows now come together. This is the great part about the flowchart. You see where the ideas all work out. So if I know that they're congruent, angle 2 and angle 4 are congruent, and angle 2 and angle 4 are supplementary to two other angles, I know that angle 1 is congruent to angle 3 by the congruent supplements theorem. And again, not a big deal. We're not really going to go over this very much, that congruent supplements theorem, because you can easily do it with that definition of supplementary and all that, okay? And then once I know that these two angles are congruent, the definition of congruent angles, or definition of congruence, tells me that the measures are equal. Angle 1 is equal to the measure of angle 3. And then you can always do all of your ideas kind of linked together, right? It all works out. You have different given information, right? And it kind of gets smaller and smaller until you come to one final statement, which should be what you're trying to prove, all right? Again, I really like this as a brainstorm because you can put all these boxes around and start playing around with your arrows and see what makes sense and what sequence makes sense. So that's the flowchart. The next one we're talking about is a paragraph proof. So we're going to take that same two-column proof and write it as a paragraph. And when you're writing it as a paragraph, it's exactly that. You're writing a paragraph. So you're going to use your statement and your reason, and each of these is going to become a sentence, right? So statement 1 and reason 1, for example, these two should be my first sentence, right? And then statement 2 and reason 2 should now become my second sentence. Right, and it's really going to be this happens because of this reason, and you're just going to rewrite all this in sentences. And for some of us who are maybe a little more literary minded, do like the paragraph proof. And when you look at math journals and things in higher level math, you actually see everything written more like a paragraph proof because that's how academic writing is. So it doesn't hurt to practice this as well. So all we're going to do is rewrite this so we have, for example, for that first sentence, angle 2 is congruent to angle 4 because that's some given information, right? Just something that tells me what you know, which is your statement, and why, which is the reason. So I'm going to type this out, and you can take a look and see how that makes sense. All right, so there's my first sentence. Again, you can write it with whatever wording you feel like is your style, but this is just one way to do it. The first sentence, it is given that angles 2 and angle 4 are congruent. Then you can say, by the linear pair theorem, angles 1 and 2 are supplementary. Oops, get rid of that capital A. And angles 3 and 4 are supplementary. Right? So again, what the statement is and how do we know that? Okay. Then I can say it follows by the, I can say it follows that angles 1 and 3 are congruent by the congruent supplement theorem. Space in there. Right, so that's statement 3, reason 3. Therefore, the measures of angles 1 and 3 are equal by the definition of congruent angles. Right? And there's an example of a paragraph proof. Sorry, I tried to space it a little more so you can see it in the white space. But you can see how it basically just takes statement 1, reason 1, as sentence 1, right? And so on. I would usually say don't go straight to a paragraph proof. Personally, again, you can see hopefully how once you have it in two-column proof, it's easier to write that as a paragraph, right? Or going from the flow chart, seeing how everything connects and then writing that as a paragraph. So again, it's up to you what you want to write as your final product as your proof. But again, I personally brainstorm with the flowchart. I write things to the 2 column because it's a little shorter in terms of how much writing you have to do, but be able to understand a paragraph proof, right? Because that might be something you're reading. Okay. So lastly, you guys are going to take this now, take a look at the flowchart proof, and I want you to break it back down to the 2 column proof, and then write that as a paragraph proof, just to practice those different, interacting with those different forms. Remember, what you need to make sure you're doing with the flowchart proof to go from the flowchart to the 2 column is never write down something that an arrow points at without writing the stuff above first. So you wouldn't write the measure of angle 1 is equal to the measure of angle 3 as statement 1 because you need to know that angle 1 is congruent to angle 3 first. So just be careful with that flow, right? We can't say the measure of angle 2 plus the measure of angle 1 equals 90 degrees until you've got both the measure of angle 1 equals the measure of angle 3 and the measure of angle 2 plus the measure of angle 3 equals 90 above that. All right, so we'll talk about this when we get back to class. Hopefully this gives you some more options and come back with questions. See you guys later.